Hello everyone. I'm Dr. Abhinaya Inbamani from University of Florida, NFREC, Quincy. When science meets technology, farming becomes smarter, greener, and more inspiring for the next generation of innovators. From sensors and circuits to AI and automation, we explore how the innovation transforms the farm, food, and the future. Get ready to imagine, design, and create because learning here means bringing STEM to life in the field. Today, we begin our very first session, Smart Strawberry, the Digital Irrigation Lab, where we will build a basic LED circuit in Tinkercad, the foundation for our smart irrigation system. By the end of the session, you will know how to design a simple LED alert system, calculate the safe resistor values, and understand how this concept connects to water management in agriculture. In precision agriculture, water management is the key. Our simulation mimics how a farmer gets notified the moment soil dries out, so irrigation happens at the right time. Let's break down the three basic but crucial concepts. V, I, and R. I. I represents the current. Current refers to the flow of electric charge or electrons through the conductor. It's like a water flowing through a pipe. The more the current, the more electrons are moving. It's measured in ampere. Resistance. Resistance is the opposition to the flow of current. It limits the amount of current that can pass through it. It's like a narrow pipe restricting the flow of water. Resistance is measured in ohms. V. V represents the voltage. Voltage is the potential difference between the 2 points in a circuit. It's like a push that drives the electric current through the circuit. Think of it as the water pressure in a pipe. It's measured in volt. Ohm's law is the fundamental relationship between the three concepts. V, voltage in volts. I, current in amperes. R, resistance in ohms. With this knowledge, let's start to work on designing our circuit. You can go to your browser and type tinkercad.com. I will pause then and there so that you can do it along with me. Tinkercad is a free browser-based simulation tool by the Autodesk that lets you design and test the electronic circuits without requiring the physical components. We have two options in the Tinkercad, Login and Sign Up. Click Sign Up. Create a personal account using your mail ID. You can just click that option. Try signing with Google. And now you are into the dashboard of Tinkercad. Click Create. In the Create, we have three options available: 3D design, circuits, and code blocks. Click Circuits. There is a search bar option present on the right-hand side in order to find the required components to do your project. Let's try to bring the components into our dashboard first. Let's search for breadboard. Breadboard small would be sufficient for the project what we are doing now. Try bringing breadboard small onto your workspace. Let's take a closer look at one of the most important tools in electronics, that's the breadboard. The reason is because breadboard does a lot of work. A breadboard is like a rectangular plastic board which has filled with the tiny holes arranged in rows and columns. These holes are connected underneath by the metal strips that allows the electricity to flow between the components without soldering. The two long lines running along the top and the bottom are the power rails, one for positive and one for negative. The smaller holes in the center are the terminal strips, which is divided by a middle gap known as the trench. When you insert any component like a LED or a resistor, each leg will sit in a different row so they can be connected through these internal strips. This design makes it easy for us to test, adjust, or rebuild any circuit, perfect for learning and experimenting virtually in Tinkercad and in real life. The second important component is the LED. LED means light emitting diode. The word diode comes from di, meaning two, because every LED has two terminals, the anode and the cathode. The anode is the positive leg, slightly longer, and it connects to the power supply. The cathode is the negative leg, shorter, and connects to the ground. Next, we have the resistor. Its purpose is to limit the amount of current flowing through the circuit. Without a resistor, too much current could pass through the LED and burn it out. The last component required is a battery. It has two ends, the positive terminal and the negative terminal. When connected correctly, the battery provides the energy that allows the electricity to flow through the LED and make it glow. Now let's start giving the connections. Place the red LED onto the breadboard across the two rows. You can choose any two rows. Connect the resistor to the anode of the LED. Connect the other end of the resistor to the positive rail. Connect the cathode of the LED to the negative end of the battery. Connect the battery's positive terminal to the breadboard's positive rail. Click Start Simulation. The red LED should light up. Rename the project to your desired preference. You can use the Send to option and share with your peers or your teacher. With this, we have completed our experiment on building a basic LED circuit in Tinkercad. If you're curious about how we calculate the correct resistance value to protect the LED, continue watching. We will explore that next. So, the power supply voltage we have used here is 9 volt and the LED forward voltage is 1.8 volt to 3.3 volt. This difference is because of the changes in the color of the LED. You can change the color of the LED here as well. The desired current of the LED is 10 milliamperes to 30 milliamperes. The typical safe operating current for the standard LEDs. Higher the current, brighter light but shorter lifespan. So let's start to use the Ohm's law and find the value of resistance. We know the formula of Ohm's law. V is equal to I multiplied by R. So to find the value of R, we write V divided by I. We have the power supply voltage and the LED forward voltage. With that, we will be able to calculate V. So 9 volt subtracted by 2 volt divided by 20 milliamperes. From 1.8 volt to 3.3 volt, I have chosen 2 volt because that's a typical forward voltage for a red LED. And the safe LED current is 20 milliamperes. That's the reason why we have chosen 2 volt and 20 milliampere. So we get 7 volt divided by 0.02. And we get the resistance value as 350 ohm. This is the ideal value of resistance which should be used if a red LED is preferred. Try changing the value of resistance in your project. Just click the resistance and change the value as 350 ohm. And give start simulation. Giving a proper value of resistance is really important. So we have seen how to find the resistance value with a given value of voltage and current. Every resistor has a set of color bands like this that tells us its value. So these colors, it represents the numbers, the multipliers, and the tolerance range. Let's take a closer look at it. Imagine we have a 4-band resistor. In a 4-band resistor, the first 2 bands are the digits, the third band is the multiplier, and the fourth band shows the tolerance value. In a 5-band resistor, the first 3 bands are the digits, the fourth is the multiplier, and the fifth is the tolerance value. For example, let's take a look at this resistor. The first band is brown, so brown represents the value 1. The second band is black. Black represents the value 0. The third band is orange. As it is a 4-band, the third band represents a multiplier. That's the reason why we write 10 to the power of 3. And the tolerance band, gold or silver, tells us how accurate the resistor is. For gold, it's plus or minus 5%, and for silver, it's plus or minus 10%. So here you can see it's gold, which means the tolerance value is plus or minus 5%. This color system helps us to identify the resistor values quickly without reading any printed numbers. Now let's take an example. Orange, green, brown, and gold. Try guessing the value of resistance. Let's take for orange. The value of orange, you can see that it's 3. The value of green is 5. The value of brown in terms of multiple is 1. So we need to write this as 10 power 1. G represents gold, so the tolerance value is plus or minus 5%. So the value of resistance over here is 350 ohm resistor with a tolerance of plus or minus 5%. So this is how the color code chart should be looked at. Thank you for watching this session. I hope you found it useful and enjoyed learning something new today. See you all in the next session. Until then, happy learning and keep exploring science with technology.